A Formula One car uses octane as fuel. Octane is an organic compound that contains only carbon and hydrogen. During one lap of the Singapore Grand Prix, a Formula One car used up 2.964 kilogram of octane. So one lap, 2.964 kilogram. Octane contains 84.2% carbon. Using this information only, determine the empirical formula of octane. So, which means that the remaining 100 minus 84.2%, the remaining would be the hydrogen. So, in order to determine the empirical formula, we need to make the table, and this table should consist of carbon and hydrogen. First is percent, so it's given 84.2. So your hydrogen would be 100 minus 84.2, and that would give you 15.8. Then after that, we need the AR. So the AR for carbon is 12, and for hydrogen it is 1. Now it is very important to know that for finding empirical formula, we use the atom, carbon atom and hydrogen atom, not hydrogen gas, not H2, but the hydrogen atom, which is H. And after that, we have the mole. So in order to find a mole, we assume this percentage to be the mass, to be 84.2 gram. So in order to find a mole, there'll be 84.2 divided by 12, and that will give you 7.0166. Okay, likewise for hydrogen, 15.8 divided by 1, that will be 15.8. Then we have mole ratio. So for the mole ratio, we have to divide the mole by the smaller mole. And in this case, the smaller mole is 7.0166. So we divide 7.0166 by 7.0166, and that will give you 1. And likewise for 15.8, we have to divide by 7.0166, and that will give you 2.25. This is the mole ratio. Then how about the simplest mole, or the simplest ratio, simplest mole ratio? So in order to find the simplest mole ratio, the mole ratio must be a whole number, or it can be slightly above, slightly more than, or slightly less than a whole number. So in order to do that, now is 1 is to 2.5. So 1 is to 2.5. So in order to make both of this as a whole number, we need to multiply. Let's say we start with multiplying by 2. So 1 times 2 is 2. 2.25 times 2 is 4.5. So still not yet a whole number. So we start, next will be 3. 1 times 3, that will be 3. And 2.25 times 3, that will be 6.75. And we cannot round up 6.75 to 7 because it's the gap is too big. So then we go to the next number, which is multiplied by 4. So 1 times 4 is 4. 2.25 times 4, that will give you 9. So very nicely, 4 and 9 would be the simplest mole ratio. Therefore, the empirical formula of octane is C4H9. This is the empirical formula for octane. Next, 26 mole of octane is consumed when the car completes 1 lap. And before that, in the question, it says 1 lap, 2.964 kilogram of octane. Calculate the molar mass. What is the meaning of molar mass? Molar mass is mass of 1 mole, and the unit is gram or gram per mole. That is the molar mass. And you need to also know that molar mass is actually the same as the MR in gram or gram per mole. So for example, carbon, the AR for carbon is actually 12. It also means that the mass of 1 mole of carbon, the molar mass carbon is actually 12 gram or 12 gram per mole. So molar mass and mass, value-wise, they are the same. The difference is molar mass has a unit, which is gram or gram per mole, but AR doesn't have a unit. Yeah, so in this case would be the MR, molar mass of 1 mole. So let's 26 mole. So that means 2.964 kilogram of octane, 1 lab, right? And we also need to, you should also know that this 2.96 kilogram of octane is actually 26 mole. Yeah, because of this 1 lab also. This is 1 lab, this. So 2.964 kilogram of octane is 26 mole. 2.964 kilogram is 2964 gram, is actually 26 mole. Yeah, so from the triangle, mass, mole, MR, we can find out that the MR is actually the mass 2964 gram, okay, which is this one divided by 26, and the MR is 114. The MR is 114, therefore the molar mass is 114 gram, or 114 gram per mole. Yeah, because molar mass and MR are the same. So this is part B. Part 1. Let's look at B part 2. Using your answers from A and B1, determine the molecular formula. Now remember, molecular formula is multiple of empirical formula. That means empirical formula, multiply a whole number, that would give you a molecular formula. So we know that C4H9 is the empirical formula. Yeah, so the multiple of it, this is the multiple. And from here, we know that the molar mass of octane, that means that the molar mass of the molecular formula of octane is actually 114. So the MR for this molecular formula of octane is actually 114. This is the molecular formula. This is the empirical formula. So this is the multiple. So the MR for this is actually octane, is 114. So you multiply the N inside, that would be the MR C4N 9 H9N 114. So how do you find the MR for this? You have to multiply the AR. So 12. AR for relative atomic mass for carbon is 12. So 12 times 4N plus relative atomic mass for hydrogen is 1. 1 times 9N, and that will be 114. So this is 48N, this is 9N, so total 57N, and that would be 114. So the N is 114 divided by 57, N is 2. And when N is 2, can you find out the molecular formula? So this is the molecular formula, C4H9, the N is 2, so which means C8H18. So this is the molecular formula for octane. Let's look at part C. So part C is for the entire Grand Prix, which is 61 laps. So before that, we only deal with one lap. So now it's a total 61 laps. Find the volume of octane. Yeah, so octane is a liquid. So this is a liquid volume. And the question actually give you the density. What is more important is that the density, this 700, gives you the relationship between the mass of octane and the volume. Yeah, so from the mass of octane here, we can find out the volume, because the question asks you to find the volume of octane. So 2.964 kilogram is for 1 lap. So for 61 lap, okay, the mass of octane required for 61 laps would be 2.964 kilogram, 61 laps. that will be 180.840 kilogram. This is for the entire Grand Prix. But the question wants volume. So how do you change kilogram to volume using this density? So this 700 kilogram per cubic meter means 700 kilogram 1 cubic meter. So 700 kilogram of octane, the volume is 1 cubic meter. So now for 61 laps, we would need 180.804 kilogram. Yeah, so for the volume required would be 180.804 divided by 700, and that will give you 0.258 cubic meter. But the question wants volume in dm cube. So what is the relationship between dm cube and cubic meter? So you need to know the relationship between meter and decimeter and dm. So you need to know 1 meter is 10 decimeter. Okay, 1 meter is 10 decimeter. So 1 cubic meter be 10 times 10 times 10, which is 1000 decimeter. Yeah, so very straightforward. So the volume of octane would be 0.258 cubic meter times 1000. That would change it to decimeter, dm cube. 258 dm cube. That's for part C. Thank you for watching. Bye bye.